For thousands of years, humanity has looked upward and believed the night sky was something orderly, almost complete. Ancient civilizations traced patterns among the stars and imagined gods, hunters, beasts, and stories written in light. To them, the heavens appeared fixed, eternal, understandable. Early astronomers mapped celestial motions with astonishing precision, while philosophers debated whether the universe was finite or infinite, whether existence itself had an edge. As science gradually replaced myth with evidence, a powerful idea emerged. Perhaps the cosmos, vast as it seemed, could eventually be understood. But the universe has a habit of resisting certainty. Every time we think we have grasped its structure, something appears that reshapes the picture. Something deeper. Something stranger. And now, once again, that is happening. A single machine is pushing the boundaries of what we thought we knew. The James Webb Space Telescope is not merely a more advanced successor to earlier observatories. It represents a fundamental leap into a new era of exploration. With its enormous gold-coated mirror and unmatched sensitivity to infrared light, it can detect signals that have traveled for more than 13 billion years. Ancient light. Light emitted when the universe was still young, when the first stars were only beginning to ignite. In a very real sense, it allows humanity to look backward in time. Before Webb, the Hubble Space Telescope had already transformed our understanding of reality. Its famous deep-field images revealed one of the most astonishing truths in astronomy. Empty space is not empty. When Hubble stared into what appeared to be a dark, insignificant patch of sky, it discovered thousands of galaxies. Not individual stars, but entire galaxies. Each one containing billions of stars, perhaps trillions of planets. Entire cosmic systems hidden within what once seemed like nothing. That single observation reshaped perspective. It suggested that the observable universe contains hundreds of billions, perhaps even trillions of galaxies. Yet even Hubble had limits. The oldest galaxies emit light stretched by cosmic expansion into infrared wavelengths beyond visible detection. To truly see the earliest chapters of cosmic history, something more sensitive was required. That is where Webb began its work. When it unfolded its mirror in the cold silence of space, astronomers expected clearer confirmation of existing theories. Instead, they found surprises. Profound ones. Its first deep images revealed astonishing numbers of distant galaxies. In some images, nearly every point of light is a galaxy. Every faint speck represents billions of stars. The scale becomes almost impossible to comprehend. Because within each of those galaxies could be countless stars, countless planets, and perhaps conditions for life. But the greatest shock was not just how many galaxies Webb observed. It was how they looked. According to standard models, the early universe should have been chaotic. Young galaxies were expected to be small and irregular, gradually forming structure over billions of years. But Webb is revealing something unexpected. Some of the earliest galaxies appear mature, large, structured, organized, as though they evolved far faster than predicted. This creates a serious puzzle. Some of these galaxies existed only a few 100 million years after the Big Bang. And yet, they already show signs of advanced development. Even more surprising, some contain heavy elements like carbon and oxygen. Elements formed inside stars and spread through supernova explosions. For them to exist, earlier stars must have already lived and died. But how could that process have happened so quickly? This question has triggered one of the most exciting debates in modern astrophysics. Perhaps galaxy formation occurred faster than expected. Perhaps early star formation was more intense. Or perhaps our models are incomplete. Whatever the answer, the timeline of cosmic history may need revision. And that is extraordinary. Because few things in science are more foundational than how the universe evolved. But galaxies are only part of the story. There is another pattern Webb is revealing with remarkable clarity. The large-scale structure of the universe itself. Galaxies are not scattered randomly. They are arranged in an immense network known as the cosmic web. Vast filaments stretch across hundreds of millions of light years. Between them lie enormous voids. Together, they form one of the largest structures in existence. A web spanning the observable cosmos. These structures are shaped by gravity and influenced by something even more mysterious. Dark matter. Dark matter cannot be seen. Yet its gravitational pull shapes galaxies and clusters, acting like an invisible framework holding the universe together. And still, even dark matter may not explain everything. Some structures appear more developed than expected. Once again, the same question returns. Did the early universe evolve faster than we thought? Scientists do not yet have clear answers. And that uncertainty is what makes this moment so important. Because discovery often begins where certainty fails. Webb is not breaking our understanding. It is refining it. Pushing it forward. Another realization